Today, many people, if not the majority, believe that the discovery of life on other planets is only a matter of time. Do you agree with that? All the advances we have made in understanding the process of life's emergence here on Earth and in learning about the nearly infinite extent of the universe seem to point in that direction. Based on what we know so far, it seems that everything converges to a single point: probability. It is true that all the events necessary for life to arise, develop, and persist are extremely rare and challenging, but it is also valid to think that in a universe as vast as ours, the chances of this happening simply outweigh the odds. Therefore, our efforts to find evidence of life beyond our planet and perhaps even establish some form of contact are becoming more serious and mature. An example of this is the establishment of the SETI Institute, which aims to unify and standardize international efforts with the same goal. In the video I mentioned, we present the principles established by the institution that will guide research and announcements when we finally find the evidence we are looking for. So, go check it out after this video ends, okay? Well, from there, today we will analyze another possible and quite exciting piece of evidence that we are on the right track in our searches. Scientists from around the world are detecting an electromagnetic signal that is being sent every 22 minutes in our direction. And that's not all. They have discovered that this pulse, or perhaps this message, has been reaching us for at least 35 years. Curious, isn't it? So stay with us to better understand this phenomenon. First of all, let's clarify some points so that we can better understand the relevance of this finding. Most of the references we have about the real discovery of extraterrestrial life come from numerous fictional works on the subject, be they books, movies, series, and so on. It is natural for this to happen. After all, this is a subject that has been dear to humanity and has piqued our interest for thousands of years. However, we need to consider that much of the content produced through these works does not have a faithful connection to reality, mainly because that is not their purpose. Even though they have a significant influence on us and shape the popular imagination, we cannot take most of them into account when it comes to the scientific research conducted with the serious intent of finding extraterrestrial life. This means that yes, we are probably getting closer and closer to finding this evidence. But it's unlikely that it will come through an alien invasion or even a spaceship that had to make an emergency landing on Earth due to intergalactic mechanical problems. Mind you, we're not saying that all of this is impossible. Because, to maintain a good scientific view of the facts, it is necessary to consider all imaginable possibilities. However, it's unlikely that things will happen this way. Also, if there were an interplanetary communication and transportation network, we probably would have intercepted some signal, especially if it were established in our neighborhood, in the Milky Way, unless the means they use are so advanced that it would be impossible for us to detect or interpret them. Since this more futuristic or fictional path, so to speak, is not yet accessible to the instruments available to us so far, it's better to focus our efforts in a direction where we can actually reap some rewards. Do you agree with that? That's exactly what we have been doing so far. The various probes, among other devices sent into space, such as Voyager 1 and 2, the Hubble Space Telescope, and more recently, the James Webb aim, among other things, to better understand the parameters of our universe, and to search for any evidence that may support the hypothesis that there is life beyond Earth, whether it be intelligent or not. And here we come to another point. As unexciting as it may be compared to finding beings similar to us, with whom we can learn about the mysteries of the cosmos and engage in interplanetary cultural exchanges, it is much more likely that the first evidence we find of extraterrestrial life will be simple signatures, such as unicellular organisms or even traces of the past, like fossils. Well, this maxim mainly applies to our region of the solar system. These are the signs we seek when embarking on missions to Mars or Jupiter's moons, for example. And don't be fooled. Don't think that evidence of microbial life or fossils is small or simple proof. They would certainly change many of the concepts we have established so far. With them, we could learn about the parameters that support the emergence of life and, most importantly, which events could be severe enough to cause a definitive mass extinction. From these, we could even take a step towards finding other homes to shelter our civilization, if necessary. After all, one day, it may be the only way to survive and perpetuate our species. Have you ever stopped to think about that? Well, I find all of this very exciting, you know. However, even though this method is the most likely way for us to find evidence of life beyond Earth, at least for now, it's not the only one. As we said, we are constantly on the lookout to intercept any signal that is sent, intentionally or unintentionally, in our direction. But how is this done exactly? Are there teams of scientists checking NASA's email inbox for news? Of course not, right? However, as naive as this question may seem, it reveals a fundamental difficulty in the search for this type of evidence. That is, regarding possible messages sent to us, how is it possible to detect these signals if we don't even know which instruments could be used? And more importantly, how would we interpret them? Well, if here on Earth we already face various difficulties in communicating with people from different cultures, imagine how it would be with a species from a different planet that had a different evolutionary process and basis to assert its existence. In fact, anything we try to speculate from here is pure speculation. On our planet, we know that life originated from water. Most living beings need oxygen, which is the basis of our material form of life. Our bodies are carbon-based. We have 5 main ways of perceiving stimuli from our environment, that is, our 5 sensory senses. But we cannot assume that any form of intelligent life in our universe has these same attributes. As we have already mentioned, the vastness of the cosmos makes the possibilities for combination and evolution almost infinite. That is why the attempts we make to communicate so far are limited and often criticized. But they should not cease to exist because, as they say, nothing ventured, nothing gained, right? However, as everything indicates, a very promising way for us to intercept some signal, and perhaps one day communicate with other civilizations, is through electromagnetic radiation, such as radio waves. Now we can better understand the importance of this signal that we have captured and that we have been receiving every 22 minutes for about 35 years. The discovery was made by chance, like so many others throughout human history, but let it be clear that this in no way diminishes its merit. On the contrary, the achievement is even more surprising for having been conceived by a student, Tyrone Oldworthy, who was only 20 years old at the time. Tyrone joined the International Centre for Radio Astronomy Research in Australia with the aim of designing a program that would help investigate the radio waves that propagate through the universe. By the way, do you know what these radio waves or the electromagnetic radiation we mentioned earlier are? No? In simple terms, electromagnetic radiation is an oscillation of electric and magnetic fields that propagate through space as waves. One of its main characteristics is the fact that it carries a lot of energy because it self-sustains when disconnecting from the electric charges of its sources to connect to others along the way. It may seem complicated, doesn't it? But consider examples like light, the same light that emanates from our sun, and radio waves, as we mentioned earlier. From there, you can get an idea of what we're talking about. However, don't worry about understanding everything at once. For our purpose in this video today, it is enough to understand that this type of radiation can travel very, very long distances. Just for this reason, you can imagine why scientists rely on this type of signal to establish some form of communication with other civilizations, right? If this type of wave is similar to the ones we use on Earth to send and receive information, why not bet that, in some way, other life forms would do the same? If there is a more efficient way to establish interplanetary dialogue, it is likely that we have not yet discovered it. Here on Earth, the instruments we use to receive this type of signal are called radio telescopes. As the name suggests, they are similar to optical telescopes, but instead of observing the spectrum of visible light for us, they focus on frequencies that we cannot see with the naked eye, radio waves. Well, ironically, our undergraduate student was just writing the lines of code for the program that would be responsible for interpreting the signals received by the university's astronomy program radio telescope. However, when analyzing some of this data, he came across this intriguing signal, mainly because of its periodicity. Immediately, he reported to the research team leader, astrophysicist Natasha Harley-Walker. With the efforts taken among their peers, they moved on to more detailed analyses of the phenomenon. The first thing that immediately caught their attention was the periodicity of the signal. It was detected every 22 minutes, on average, and lasted up to 5 minutes most of the time. In fact, there weren't so many surprises up to this point. Some crucial information was still missing. I say this because, with the advancement of technologies capable of detecting this type of signal, such as radio telescopes, scientists have realized that there are various celestial bodies that emit similar traces. An example of this is pulsars, supermassive stars composed almost entirely of neutrons. As we know, stars are like giant furnaces that forge increasingly heavier elements in their cores, starting with the simplest one, hydrogen. As the elements become increasingly complex or heavy, the star tends to collapse in on itself, going through various phases that can lead it to become a supernova, scattering material throughout the universe, or a black hole that sucks everything around it, including light. Depending on the conditions and especially its mass, this star may become a white dwarf, composed of the neutrons we mentioned earlier. Neutrons are neutral charged particles that make up the core of atoms along with positrons, which have a positive charge. Electrons, on the other hand, are the elements that populate the cloud around the nucleus and have a negative charge. Too much information. For us, the important thing here is to understand that this type of star, white dwarfs, is extremely massive. So massive that a white dwarf with the mass of the Sun would have a diameter of only 20 kilometers. If we could put a quantity of its matter in a teaspoon, it would weigh more than the combined weight of 8 billion humans. Getting a sense of it, right? That's it. Due to these characteristics, this type of star tends to spin around its own axis very, very rapidly, creating a magnetic field that, among other consequences, emits radio signals throughout the universe. Since they reach us periodically, they are known as pulsars and are compared to the signals emitted by a lighthouse. Therefore, the first hypothesis of the team that detected the signal in Australia was that it was a pulsar. However, despite being emitted at a certain frequency, they tend to be faster and not always so regular, as they often show variations. So the next step for the team was to try to categorize the signal as a magnetar. But don't be alarmed, this time we won't have elaborate explanations. Just understand that a magnetar is a signal similar to a pulsar, but it comes from much more powerful and complex magnetic fields capable of emitting signals over long distances and for several months before ceasing. Even so, the signal captured by Natasha and her team still seemed strange, mainly due to its regularity. Even if it came from a powerful magnetar, it should vary more frequently. Based on this, they brought the case to the international scientific community and requested access to data collected by other radio telescopes. Here came the biggest surprise of all. The data collected in Australia not only were corroborated by observations made in other parts of the world but also showed that the signal had been received by us for at least 3 decades. However, due to its specific characteristics, it had not been observed with the necessary care and had been going unnoticed by researchers. The hypothesis that the signal comes from a magnetar has not been completely ruled out because it could be a natural phenomenon that has not yet been observed or understood by us. However, many researchers also do not rule out the possibility that the signal is emitted by a non-natural source. In other words, it could be produced and intentionally sent by some form of intelligence because its regularity and constancy are unprecedented factors in our investigations. So far, we have not discovered the source responsible for these emissions, and the signal remains a mystery to us. Perhaps it is some astronomical object that we have not yet encountered, which will advance our knowledge of the universe. But who knows, maybe we are finally facing evidence that there is indeed intelligent life on other planets. In any case, as always, any updates regarding this or any other evidence will be found here at Astrofyx. I'll leave it at that, but I'll see you again soon. Until next time, take care and goodbye.